we have a new definition here. A vector whose initial point is at the origin is called a position vector. So these vectors that we've been writing in terms of I and j are position vectors. Okay. And the next thing that we're going to do here is we have a vector that's actually not going to be a position vector, but we're going to try and make it one. Okay, we're going to move it or find. We'll see. Let's sketch in our axes. All right, so there are our axes. Let's go ahead and sketch in a vector. There's our vector. And it's what we're going to do with it, though, is we're going to try and move that vector so that it starts at the origin. Okay. So I'm going to try and sketch the exact same one here. I think that looks pretty good. Okay. And this thing is going to have a location where it starts and where it ends. Okay. And so let's just say that this is x1, y1. And we'll say our other point is x2, y2. Okay. So remember, two vectors, they are equivalent as long as they have the same magnitude and direction. Okay. And you can see that these two vectors we've sketched, they look the same length and they look like they're headed the same direction. So really our only goal is to take this vector here and figure out how we could rewrite it in terms of I and j. So in other words, if we were to take this vector and place its initial side at the origin, where would its terminal side be? Okay, this is what we want to know. What is that point? That would give us our I and our j. Okay. So in order to figure that out, it would be nice to know, first of all, well, how tall is this vector? Right? Well, from this picture, it's kind of hard to tell. But from this other one, it's really easy to see its height. You could just subtract the y values, y2 minus y1. And if you wanted to find the length of the base, that would also be really easy. That should be x2 minus x1. So the length of the base over here should also be x2 minus x1. And the height should also be y2 minus y1. All right, and so is what that tells us then is this point that we're really interested in is actually x2 minus x1, comma, y2 minus y1. And so that there are going to be the numbers that we're going to write in front of I and j. So right here at the bottom, we're going to be writing v is equal to x2 minus x1 I plus y2 minus y1 j. Okay. And so that's all we have to do. If it doesn't start at the origin, but we want to write it in terms of I and j, all we have to do is subtract the x values, write I next to it, subtract the y values, write j next to it. All right, and we're going to try that right now. So v is going to be a vector that goes from P1 to P2. Okay, and so if we're looking at how far this thing moves horizontally, that's just the distance in the x values, or if I wanted to, I could subtract them, -4, -1. Okay. And I'll write I next to this. And then if I want to find the change in y, okay, well, I can also just subtract those, subtract my y values. Okay. And you might be noticing in what direction or which values I chose to put first and second. Okay. Well, remember, I want this number here to be the number that represents how far we've moved horizontally. And so if we went from 1, 2 to -4, 8, that means we've actually went 3 units, or sorry, not 3, -5 units over, or 5 units to the left. Okay, so let's write that. This is -5i, again, because we're moving left, not right. And we're also moving down, aren't we? So since we're moving down, we also expect this one to be negative. -8 -2, so that's -10j. So this here is our final answer. And again, the only thing you got to be careful about when you're doing these is that you subtract these in the correct order. It should always be the terminal point minus the initial. Okay, terminal minus initial, or P2 minus P1. What I'd like us to do from here is see how we can add two vectors together when they're written in terms of I and j. And to begin that process, let's actually sketch in two vectors and add them together. So let's maybe say that this one here is v. That looks good. And let's sketch in another one, w. And then lastly, we'll sketch in the vector v plus w. Okay, right? We know that if we add two vectors, right, we're supposed to add them head to tail. Okay. Well, if you think about how far v plus w goes over, well, it just goes over. Let me actually maybe sketch in a line here. It goes over the distance that v goes horizontally plus the distance that w goes horizontally, right? So if we want to add v and w, we should at least add their horizontal components. But let's think about what to do with their vertical components. Well, v plus w, it goes up vertically the amount that v goes up plus the amount that w goes up. So if I want to figure out what the vertical component's going to be, it's just the sum of the two vertical components. So plus b1 plus b2 j. So this is really easy to add these when they're written like this. And subtraction is going to be in really the same format here. We have a1 minus a2i plus b1 minus b2j. And let's go ahead and do a couple examples. So down here, we're asked to find the sum of v and w, the difference of v and w. So if we're going to do that, again, we first add these horizontal components, 3 and 8, so that's 11i. And then we'll add the vertical components, 4 plus -7, so that's minus 3j. And then subtracting them is going to be just as easy. 3 minus 8, so that's minus 5j. or minus 5i, and then 4 minus negative 7. So that's 11j. So plus 11j. And now you might be wondering, well, if we're writing things in terms of I and j, how do we add them? Or how do we multiply by a scalar? Okay. And this will also be simple. All we're going to do is you just multiply each component by k. So this will be a times ki plus b times kj. And that's it. Let's try a couple more examples. So minus 2v. So we're just going to take this vector and multiply it by minus 2. Or multiply each of its components by minus 2. So minus 2v is equal to minus 18i. And then minus 2 times 6, that's minus 12j. Is what I'd like us to do here next is example 6, and I think it'd be worth pausing the video and trying out parts A and B here. So what I'm going to do to start this off is I'm actually going to compute 3u and 4v separately. That way I can easily add them together. I don't want to have to do all this in my head here. So 3u, this is going to be equal to 6i, and then 3 times minus 5, so that's minus 15j. And we'll do the same thing with v, except for with v we want to compute 4v. And so this is minus 12i, and then 7 times 4, so 28j. And so if we were to add these two vectors together, specifically 3u and 4v, well, that should be 6 minus 12, so it's minus 6i. And then minus 15 plus 28, that's going to be 13, and so it's 13j. All right, part B, we want to find the magnitude of u minus 6v. Let's just start off by just reminding ourselves of what u looks like. It's 2i minus 5j. And let's also try and think about what's minus 6v look like. That should be minus 6 times this vector up here. So that's 18i. And then minus 6 times 7, so that's minus 42j. And so what that tells me is u minus 6v should just be equal to the sum of these two vectors up here. So that's 20i minus 47j. That's what we're going to find the length of here. Okay. All right, now we can actually find the magnitude of u minus 6v because we found the vector u minus 6v. This should be equal to the square root of 20 squared plus negative 47 squared. So I really didn't need to write that negative in there because when I go to square that, it'll become positive. But I wrote it just so we know that this is the square root of a squared plus b squared. And the next step is if I were to square those things and add them together, we end up with our magnitude as the square root of 2,609.